Okay, so last time we say that velocity is change in position with respect to time. So it is position over time. But when there is a change in velocity over time with some time interval, that is now what we call acceleration. So when you change your velocity, for example, from 5 miles per hour, you traveled and increase its velocity from 5 miles per hour up to 10 miles per hour. Example, your velocity at time 1 is 5 miles per hour. So at some time 2, sometime there is a change in velocity from 5 miles per hour. You increase or you speed up the car, for example, to 10 miles per hour. Okay. So if there is a change in velocity along a particle has changed in velocity, V1, V2, velocity from V1 velocity 1 to velocity 2 along some time t, t1, t2, then that is what we call acceleration. Okay, provided the acceleration of a particle is be known at the 2 points. The average acceleration of the particle during the time interval delta t can be computed by this algebraic equation delta v over delta t. You change in velocity per change in time. Okay, wherein yung delta v natin is equal to the delta v is your v2 minus your initial velocity or your v1. Okay, same with delta t, t2 minus t1. Okay, so for instantaneous velocity, instantaneous acceleration. So instantaneous acceleration at time t is is a vector found by taking a smaller and smaller values of your delta t. So if we take a smaller and smaller values of your delta t, of this delta v over delta t here, we can now compute our instantaneous acceleration. Okay. Or if we do the calculus, a is equal to dv over dt. Okay, so that is our equation for acceleration. Okay, but since this velocity here, if you recall, that velocity is ds over dt, change in position with respect to time, and when we got the derivative of this dv with respect to time, we get the acceleration. Therefore, when we can also get the acceleration in a relationship with the position if we take the second derivative of the position. Okay, so from s we get the derivative of s ds over dt, so that is our velocity. And when we get the derivative velocity with respect to time, we can now define our acceleration. But if we direct from position, we only means that we need to take the second derivative of the position with respect to time in order for us to come up with this acceleration. So from here, we need to take the second derivative of the position to arrive with our acceleration. Okay. So with same with velocity, our acceleration can be both positive or negative depending upon the given velocity or given position. So both average and instantaneous acceleration can either be positive or negative. So if we have positive acceleration, we say that the object or the particle is accelerating. If we have a negative acceleration, then we say that the particle's acceleration, or it is what we call deceleration or decelerating. The particle is decelerating. Decelerate. Isa accelerate, isa decelerate. Okay? But when the velocity is constant, for example, at your initial point, the particle is 10 km/h, and while it is moving along the straight line, it maintains its velocity of 10 km/h. So we say here that the velocity is constant, meaning it doesn't have a change in velocity. It remains constant, meaning it maintains its constant velocity from 10 km/h, and at some time t, its velocity remains 10 km/h. So the change in v there is just 0. Okay, so if the velocity is 0, then our acceleration, of course, is 0. It doesn't accelerate, it doesn't decelerate. It only maintains its value, okay, its constant velocity. So therefore our acceleration is just 0 if we have a constant velocity. So for the unit of velocity, since it is a v is for example, unit of our v is meter per second, so this is your v. So, and for example, the unit of your t is also in second. So therefore your acceleration is m squared. Meter per square second, or in English we have sometimes feet per square second. What else? Basta always length divide the square of time. Length divide the square of time. So that is the dimension and the units of acceleration. Okay. So on our next video, we will discuss the kinematic equations when we have a constant acceleration. Okay. So see you on our next video.